Well, hello everyone, and welcome to the Columbia Memorial Space Center on this lovely Friday that we've got here in the Los Angeles area. Oh, it was so nice.
Well,
we
hello
had a
everyone,
little bit of
and
rain, and then
welcome
I'm
to the
going to talk to myself here a little bit, I guess. So glad to have you here today. My name is Jared. I'm one of the aerospace educators here at the Columbia Memorial Space Center. We're very excited to be talking about what's actually going to be happening this year in 2021. Yeah, we're like 6 weeks into 2021, which is fine, but there's still a lot of stuff that's coming up, a lot of stuff to look forward to, a lot of stuff that just happened this week as well. Very exciting stuff. And of course, if you're watching live, you are absolutely welcome to send your questions in. We've got our lovely live chat going there with our producer Rick helping out a little bit over there, and I've got a means by which to actually see the questions this time. So we will be able to answer them in real time and get you those answers. And if I don't know, I'll just say I don't know. So because that seems pretty fair to make that happen. So with this year in 2021, there are so many exciting things happening all over the place. So let's go ahead and just like run the gambit here and just get started with it here at the Space Center today. So super excited that we're getting to share everything that's coming up with you, and let's go ahead and get it going with what we got. All right, so everybody, we should be seeing, and Rick, give me the thumbs up when we got the nice title page right there for our year in space that we've got. And this is our first Space Center Live of 2021 as well. So very excited about that. And we've got another exciting one coming up next month that you're going to definitely not going to want to miss. So the first thing that we would like to do here is unfortunately acknowledge the passing of someone who is very important to us here at the Columbia Memorial Space Center, and that's Dr. Mary Stoffer. She was a doctor here in Downey, I believe going as far back as the 1940s, I want to say, in the 50s. And she was a benefactor and philanthropist in her retirement, and she was a tremendous monument of positivity here in the community, and constantly gave everything she could in order to help make Downey and the surrounding areas as best as they possibly could be. And here at the Space Center, we had a very great connection with her. She did fund our school district here to send every single fifth grader to do a mission in our Challenger Learning Center so they could get the experience of what spaceflight is actually like. So a life well lived, but unfortunately she passed. She was 103 years old, so a real amazing century, and a fantastic example that all of us could learn a thing or two from, and should learn a thing or two from. And kind of moving on from that, getting back into spaceflight in 2021, the first thing I want to talk about is this amazing thing that happened this week, which is that the United Arab Emirates, with their own space agency, the UAE space agency, got their first spacecraft that they have sent out to another planet in orbit this week. So on February 9th, their Mars orbiter called Hope fired its engine for 27 minutes and got itself in orbit around Mars. And it's currently in its preliminary orbit. It's not in that orbit. You can see on the screen there. And here's Mission Control as they were announcing that the burn had been successful and that the spacecraft was communicating with them and telling them, yeah, we got it. I'm in orbit. And it's just so fantastic to see another country joining the Mars Club. And it was a very exciting moment to have that happen. Hope is going to study the atmosphere of Mars and also the changing seasons and climate on Mars as well. No spacecraft has done this in the detail that Hope is going to be doing it at. So this is very exciting. This is really a spacecraft that is studying something that has not been very well studied. And its orbit is pretty high up above Mars, because it's acting just like a weather satellite here that is in orbit around Earth. You want that satellite in a high orbit so that way you can see the entire Earth with your instruments. Same thing with HOPE. It's in a very high orbit compared to most of the orbiters at Mars. That's because its instruments are taking readings of the entire planet all at once, not just little bits and pieces. So HOPE isn't like most orbiters where it's looking at what's directly below it and kind of figuring out those little bits. HOPE is looking at Mars as a whole and then figuring out things like weather and climate that's happening there. So very excited about that. The United Arab Emirates Space Agency has said that they're going to follow the scientific standards of which is that the team gets the first look at the data and they get to write all their papers and things. Then once all that comes out, they send it out for public domain. So basically anybody who wants to use the data can use the data and do their own studies and figure out their own things with it. So very exciting to have the United Arab Emirates as the 5th member of the Mars Club. And that wasn't just it. We also had China with their spacecraft called Tianwen-1. That's a shot of it separating from the rocket. And here's sort of a little animation of it going into orbit around Mars. And it did that on Thursday. Now, Tianwen-1 isn't just an orbiter. There's also a lander with a rover as well. So China is sort of doing, I sort of look at it as like a super mission for their first mission right out of the gate to another planet. So we got an orbiter, they got a lander, and they got a rover. They got like the 3 best things you can do science with. And they did successfully get into orbit on Thursday. And a very cool thing, this is actual imagery from the spacecraft going into orbit. I cannot recall any time that we've actually gotten imagery like this from a spacecraft as it's gone into orbit around its target. That's just such a cool thing to see. You see the spacecraft shaking as the engine is burning. This is definitely sped up. This is definitely sort of a time lapse because that burn, like half an hour for the engine in order to do that. But man, that's just really cool because we've never seen anything like that before. And China has also done like the United Arab Emirates, and they said that we'll let our scientists have the first go at it, which is standard practice in the scientific community, and then data goes out to whoever wants to use it. So very cool. China, 6th member of the Mars Club now. So welcome aboard and enjoy your stay. And sometime in April, Mayish, is when Tianwen-1 will drop that rover down to the surface of Mars. No hard date on that yet. I believe China is going to be taking imagery with their spacecraft first to make sure that the landing site that they've selected is actually going to be appropriate for the lander. Make sure there's no like big boulders or other things around in that area. And they're basically going to take their time and figure it out and get it right, which is great. So, because the more probes and exploration we can do, the more we can find out about Mars. And then, of course, there is the United States, which we are now just a mere, oh my gosh, what are we, 6 days away from our own rover Perseverance dropping into the surface of Mars and landing. And this is going to be really exciting because Perseverance looks a lot like Curiosity, the last rover we landed on Mars in 2012, and it is the spare parts, but it's a different set of instruments. It'll be looking for the biosignatures of life, and it will also be delivering samples for a cache system on board. And it also is going to deploy a small helicopter to the surface of Mars called Ingenuity. And that's going to be really, really exciting because that will be the first thing to fly on another planet, like our first interplanetary airplane, I guess, or heavier than air vehicle, but however you want to phrase it, it's the first in order to do that. And I love that project too, because it was a little bit of a hey, do you guys think we could actually do this? And like, well, if you can do it, maybe we could find a way to actually put it on the rover. And then they did it and they saw it worked and they said, we have to have this on the rover. So I'm really excited for it. Perseverance itself has it has a lot of instruments on board that are going to be looking for those signatures of life. It's not going to confirm whether life is or ever was on Mars. Kind of think of it as we're driving down a road, and this road is telling us that there is evidence that the things life needed were present on Mars for a long period of time, so long enough that you could have potentially had very early life startup. And we've come to a fork in the road, and we now don't know which way we should go. Should we go towards yes, there is a possibility that there would have been life on Mars, or do we go to no, the evidence is kind of showing it wouldn't have really worked out all that easily. So that's where we're at, and Perseverance is going to hopefully help guide us as to which fork in the road we can go down. Obviously, if we go down the no, doesn't really look like there was life. That's a little bit of a bummer, but a result is a result. If we then say, if we end up going down the path that says, yes, there is a possibility, a very strong possibility that life could have been here, then we get to approach the next fork in the road, which is life present, or was life ever present? Yes or no? And then that will be the holy grail question, if you will, of science on Mars. So it'd be pretty cool to get that answer. Landing is occurring on February 18th, this Thursday, and it is going to be very exciting because there are cameras and a microphone on Perseverance. So Curiosity had a camera that looked down and took 4 frames per second video. Perseverance has cameras that are going to record the parachute opening at 70 frames per second and then go to 30 frames per second. Then there's a camera looking down, just like Curiosity's, but it's going to run at 30 frames per second. And then on the descent stage, there is a camera that will watch it lower Perseverance down at 12 frames per second. And then there is another camera on Perseverance on its deck looking up, which will record video at 30 frames per second as it's lowered during this entry, descent, landing with the sky crane system. So this is very exciting because we're going to actually see what it really looks like to land on Mars. And this isn't being done just because it's cool. I mean, that is, as far as I'm concerned, a perfectly good reason in order to have these systems recording this. But it's being done because the engineers actually want to see what a parachute does when it opens on Mars, or want to see how the descent stage ignites its engines and decides to divert away. So this system, as wild and haphazard as it looks, is actually a proven system. Curiosity used a very near similar descent stage, that sky crane system right there, and it worked. So if it works, don't reinvent the wheel. So there we go. So Perseverance will be landing. It's going to be happening at about 12 p.m. Pacific Standard Time, roughly around 8 p.m. Coordinated Universal Time. So kind of convert that to your own time zone. The landing itself is a little bit later in the hour. That. And of course, I can't, if you want to watch it, it's pretty easy to do so. YouTube.com/NASA is one place you can watch it at. I'm sure YouTube.com/NASA JPL is going to have that too. And I would be I do believe a couple of the major networks in the United States as well are going to be covering it live. So check out in wherever you're at as well to see how that works out. And we'll see if you get to watch it live. I know I have cleared everything out. And I'm going to have my popcorn ready to go for this. And hopefully I don't throw the bowl when the popcorn gets everywhere. That would be fun. But it would land. So that'd be pretty cool. Now, coming up in March, towards the end of March, we have Boeing going to be doing orbital flight test 2 of their Starliner capsule. Now, back in late 2019, they did orbital flight test 1, and they had a problem with the clock on the spacecraft. The clock was not at the correct time, so the spacecraft thought it was at a different part of the mission than where it actually was. They didn't end up getting to go to the International Space Station as they had planned. So NASA and Boeing came together. They basically figured out what went wrong and how to prevent that from happening again. And Boeing said, okay, we'll go ahead and we will do another test flight. We agree that we should do another test flight and we're going to pay for it ourselves. So Boeing had to eat about $480 million themselves in order to do that. But it is way better to do a second test flight to make sure everything works correctly than it is to roll the dice with people. So as long as orbital flight test 2 goes well, we should also see Starliner carry its first crew in its crewed flight test at some point later this year. Don't know when that will be. I would imagine it will probably be in the second half of 2021. Maybe I would even venture to guess the fourth quarter of 2021. But of course, we'll have to see with that. And of course, if you all have any questions, feel free to ask them in the chat. We'll be happy to take them in real time and answer them as best we can. Now, NASA has a pair of scientific missions that are coming along. One is called DART, which is Double Asteroid Redirection Test. And this is a very interesting craft because it's going to be launched from Vandenberg Air Force Base here in California. So if you would like to see something go to another place in the solar system, come on out to California in July. We got you covered. But as you saw there, DART is literally just going to go and crash into an asteroid. So this is a asteroid called Didymos, and it is a double asteroid. And this animation you see right here is a mission that will come after DART called Hera, which will be done by the European Space Agency. They're going to go and see what DART did in its impact. So they're going to see if DART actually ended up moving the moon around this asteroid. So double asteroid. So we've got a larger asteroid in the center and a smaller asteroid orbiting around it. I guess you could call it an asteroid moon. Before they renamed it Dimorphos, they actually called it Diddy Moon, and I like Diddy Moon way better. So maybe we'll just call it Diddy Moon, or maybe the moon formerly known as Diddy, for all we know. But DART will come in in 2022, and it will impact Diddy Moon at 6 kilometers per second, and they'll see how much it has deflected the orbit when Hera goes there sometime in the mid 2020s. They're expecting a couple, like a fraction of a millimeter in movement from it. And that doesn't sound like a lot, but if you see an asteroid coming and you've got a decade and you go out there and you hit it and it's moving at a fraction of a millimeter per second over, say, like 5 to 8 years, that might be more than enough for it to miss the Earth. So this mission, DART, is really what I would consider the first mission to an asteroid to save the Earth. And it's not because we're in trouble here on Earth, because with Didymos running into us, it's because we're going out there and we're sort of going to take the offensive to the asteroid and see if our techniques that we think would work here on Earth would work. Somebody put in P Diddy Moon. I love that. And then was there another one about the naming of the asteroid? I wonder if the naming of that asteroid name was a nod to Stephen King's, I think it's a Lobstrosity. So maybe, for all I know, I think there's some mythology, probably, I would imagine Greek mythology or Roman at some point in there. Or if somebody in the chat actually wants to like Google it and can take a look and then drop it in, we will absolutely talk about that a little bit. And then there's another mission going to another set of asteroids, and this mission is called Lucy. And a little rare for a spacecraft to be named like a name, but Lucy is sort of a demonstration that us humans really have a good set of orbital mechanics. So the Sun and Jupiter, they have these points called the L4, L5 Sun-Jupiter points, where the gravity from Jupiter actually balances. And if you put an object there, it'll tend to stay in that same relative area. And those are called the Trojan asteroids. There's these two clouds of asteroids, one in front of Jupiter and one behind Jupiter in its orbit. And a lot of scientists think that a tremendous number of the leftovers from the formation of our solar system are in those asteroids. Like those are sort of the bits that didn't end up becoming planets because Jupiter's gravity pulled it in and said, no, you're going to stay in my Lagrangian points, and you're not going anywhere. So Lucy is going to be going to one of those, one side of those Trojan asteroids, and then we'll dive through the inner solar system and get to the other side. And it's going to be doing that over a very long period of time. So launching later this year in October, it will arrive at its first set of Trojans in 2026, 2027, and then it will dive through our solar system and spend 6 years getting to the other side. So it's quite a ambitious mission, and a very exciting mission too. Especially with this right here, that was a little artist conception. The final target that Lucy will be going by is a double asteroid, asteroid binary, and both of the asteroids are like 80 miles in size. So that's pretty big. So it's not like Didymos during DART, which that Didymos is a mile or two. These are behemoths out there. Some of the largest binary objects in our solar system, outside of the Kuiper belt, way far out. So pretty exciting with that. And of course, like I said, this mission is named Lucy. They named it after the hominid fossil that was found in the 70s. And that sort of the missing link fossil, which didn't end up actually being that, but it's a common ancestor of ours. And that skeleton was named after the Beatles song "Lucy in the Sky with Diamonds." And as you could tell, the team has kind of taken that and rolled with it. So not only do they have the Lucy skeleton on there, because they say that they're going to be looking at the fossils of the planets, and Lucy definitely a fossil with it there. And then Lucy in the Sky with Diamonds. So just make the mission patch in the shape of a diamond. So pretty fun team there. Was that you, Rick, who did that? No. Okay. So somebody just Googled it in our chat room, and they said apparently Didymos. Didymos was another name for Thomas the Apostle. So thank you very much for that there. That's today I learned. So thanks. I love it when our audience teaches me something. That's fantastic. So we're all learning today. Now there is InSight on the surface of Mars, landed in 2018, had a 2-year mission, and it just had a mission extension. So it'll be spending another 2 years operating on the surface. Unfortunately, the heat flow probe that was going to be used to measure the heat coming out of Mars, sort of to help with the geological understanding of Mars's interior a little bit better. Unfortunately, after a tremendous effort that was put forth by the team to try and get that mold to hammer itself into the ground, they have not just been able to do it, and they've declared it a loss, unfortunately. But the seismometer for InSight is still working really well. So are the atmospheric experiments, along with the radio experiments, to see the wobble of Mars's tilt, to see if you can maybe figure out the interior that way. But unfortunately, that heat flow probe, the MOLE, just didn't end up working. The current hypothesis is that they landed on soil that we have not encountered ever on Mars. So the MOLE is designed to basically be like a self-hammering drill. So it has a system that kind of uses friction from around it to knock itself into the ground, which is fascinating that it's able to do that. The soil around the MOLE very clearly did not allow that friction to be generated, and that is radically different from the soil that was found on Mars, that has been encountered on Mars so far. So unfortunately the MOLE is dead. It's not going to be doing much anymore. I don't think there's actually any way you can use the data from the surface from the MOLE, unfortunately. But they did get a lot of data in terms of the soil, specifically on Mars, so now they can encounter it and know what it's like, and maybe design something that's a nice balance between the soils we know of and now this new soil, this very low friction soil on Mars with it there. And of course, it will continue to take selfies. Getting a little dusty there, and it is solar powered. It's got some pretty big solar panels. And of course, it's a lander, so it doesn't move anywhere. It just stays right in that spot. So another 2 years for it there. And then another mission got a extension as well, and that would be NASA's Juno mission out at Jupiter. It arrived in 2016, and it's been in orbit since then. The interesting thing about Juno, it was actually supposed to be in a smaller orbit than it is now, but there was a problem with a system in its engine that wouldn't have allowed the engine to fire properly. So they decided to keep it in this longer orbit around Jupiter. And in doing so, they have actually saved the probe a little bit and the instruments on board. The original orbit had Juno diving super close to Jupiter through its radiation belts. And those radiation belts around Jupiter are intense. If you or I were to fly through those, we would cook very quickly in seconds. Not a good place to really send anything, especially electronics. And in fact, the electronics on Juno are inside of basically a block of titanium to try to prevent as much radiation from cooking them as possible. But because of this longer orbit, it comes in at a different angle. It still gets pretty close to the cloud tops of Jupiter, still like a couple thousand miles above, which is that's pretty close. But it comes in a little bit more under the radiation belt. So it's not really sitting in the radiation belts like they originally intended it to. So Juno's been able to last a lot longer. The instruments have been able to last a lot longer. And they have decided that they are going to go ahead and roll with that and work with that luck that they have. Because what Juno is going to be doing now is it's going to be using its instruments, very good instruments on board, to do something that hasn't been done since the Galileo orbiter was around Jupiter in the 90s and the early aughts. So in June of this year, Juno will be doing a flyby of Ganymede, just about a couple hundred miles above the surface. So that's going to be amazing. We're going to get better images than Galileo got, better data than Galileo got, and then in a couple of years, it will do a flyby of Europa, skimming just a couple hundred miles above the surface, and then eventually it will also go by Io, the inner volcanic moon of Jupiter as well. It'll do 2 flybys of Io, and it will be a little bit further off because Io is deep within that radiation belt, and also Io is pretty nasty itself. So that's a bit with it. And then once it's done that, it will it will do some very cool things, which that data that's going to gather is going to help missions like that, like Europa Clipper, and this one right here, which is the Jupiter Icy Moons, the Jupiter orbiter that the European Space Agency is working on. And then in 2025, they're going to wrap up the Juno mission by deorbiting it into the atmosphere of Jupiter, because we don't want Juno to run into like Europa and accidentally contaminate Europa, because Europa is one of those places that we think that the conditions that life needs are currently present at. And Juno will add data to that set to try to figure that out. And that's what's so exciting about this, is that Juno was not intended to study the moons of Jupiter. It was there to focus primarily on Jupiter, but they were able to figure out a way to do these flybys as bonuses with the orbits that they're doing, changing the orbit, making it smaller, so that way deorbiting is a lot easier in 2025. So I'm amped up about that. I can't wait to see Ganymede, because Ganymede is just such a cool place. Biggest moon in our solar system, bigger than the planet Mercury, has its own magnetic field. That's just wild. And we think there might be a sort of like slush ocean deep in it as well. Not like Europa's liquid water ocean that we're confident is there. But Juno will take data that should help refine that, and Juno will also help out that fleet of missions that'll be launching in the mid 2020s for arrival in the 2030s. So very cool, extra bonus science. I love it. Now, at some point this year, which it's at some point this year, China will be launching the first module, their core module, of their big space station that they are getting ready to build in low Earth orbit. And pretty neat that they're going to be able to do that they're sort of moving on their own in order to do that. And the core module is called Tianhu, which is the joining, which means the joining of the heavens, and should be an amazing project that they're working on, because the United States basically said no to China working on the International Space Station. They've said, China basically said, okay, we're going to go make our own space station. So they are. You may have heard of the 2 previous space stations that China made, Tiangong 1 and Tiangong 2. Tiangong 1 was basically like, will it work? And then Tiangong 2 is when they started to send people and crews up there. And in fact, they will send, China is saying that they're going to send 2 crews this year up to the core module. but eventually it is a modular space station, much like the International Space Station. And if you want to know more about the International Space Station, just go to our Space Center Live that we had in December. We talked about space stations in general and living and working on the space station. And it will actually be quite a sizable space station. So this is one that should be, much like the ISS, fairly easy to see from the surface of the Earth. So I'm definitely looking forward to seeing China doing their work with that and kind of moving along at their own pace right there. So you see that we've got Tianhu in the middle right there, and then we've got two other modules that have solar arrays attached to them. There's also the Tianzhou right there in pink. That's a resupply craft. No crew on that, basically supplies. So they have their own spacecraft that can deliver supplies. And then the Shenzhou over there in yellow, that is the actual spacecraft that the Chinese astronauts will fly up in. And there are some rumors going around that the next mission, Shenzhou 12, which will be the first one to go, may be the first mission from China to either be commanded by a woman or have a woman do a extravehicular activity, a spacewalk. So pretty exciting stuff coming out of them, and best of luck to them. Hope they have great success with that. And Sonia says, going back about Juno, going past Ganymede, something to look forward to in June. It's also my birthday month. So yes, they're going to get some beautiful images of Ganymede for you, Sonia. That's NASA's present for you this year. So hopefully you like what NASA gets you. That'll be happening on June 7th, by the way. Although because of where Juno is at in its orbit and other things like that, it has to kind of come out of that radiation environment around Jupiter before it starts sending the data back. So I would say probably about a week or two after that is when we'll get those first images and that first data set, which can't wait to see it because it's just been so long. It's been over 20, I would say it's been just about 20 years since Galileo sent back images of Ganymede, and Galileo is a probe that basically had instruments from the 70s and 80s. These are modern instruments from the 2010s. So very exciting for that. And let me tell you, if we're talking about something that has been around for ages, it's something that everybody's been looking forward to. It's the James Webb Space Telescope. Oh my gosh. This telescope was supposed to be in orbit back in 2007, but man, it is really tough to build a space telescope of its size. That mirror is 6.5 meters across. It is way bigger than Hubble. Hubble's only 2.4 meters. And also, James Webb is looking in the infrared, and they have to keep it cold. And James Webb, the entire spacecraft system there is about the size of a tennis court. They've got to keep it really cold, like minus 300 degrees Fahrenheit cold in that range. So and they've got to do that for years. They've got to keep all of that cold for years at a time. And you've got to have instruments that can also work in that environment for years at a time as well. It's just absolutely absurd, everything they've had to do to make the James Webb Space Telescope work. And that's because it's a primarily infrared telescope. With an infrared telescope, you're looking at the heat, if you will, the light from that coming off of an object. And that means that if you want your telescope to be able to see it, you need to have your telescope colder than the objects you're looking at. So James Webb is an incredible engineering effort when you really start to understand the fact that nobody has ever done this before on the scale that James Webb is, how big it is, let alone in the environment of space. It's amazing that we're even at this point where it's going to be able to launch. That's supposed to occur sometime in around October, in and around there. So we will see how that goes. It was supposed to launch last year, but unfortunately the pandemic slowed down work at the factory at the Northrop Grumman facility it's at here in Los Angeles, where it's still sitting at. And I saw a very interesting thing from one of the project scientists on Twitter the other day, which is that they are not saying when the shipping of the James Webb Space Telescope is occurring to its launch site in Kourou in French Guiana, because the European Space Agency basically said, we'll give you a rocket if you let us put instruments on it. And their rocket is actually the only one that has a payload fairing, or that big cone on the nose that can fit the James Webb Space Telescope, even when it's folded up. And that tweet from that scientist basically said, we can't publicly talk about when the James Webb Space Telescope is going down there because we don't want any pirates to possibly attempt to get it and hold it for ransom and things like that. And that's so wild. This right here is a sequence, a very sped up sequence of everything that the James Webb Space Telescope is going to have to do over the course of a month. It's basically going to have to unfold itself. And as you can see, there's a lot of things that need to unfold, and a lot of things that need to go right with that. So with Perseverance landing on Mars, they called that the 7 minutes of terror, because it is 7 minutes from the top of the atmosphere to the surface of Mars. I think for the James Webb Space Telescope, we could call it 1 month of horrifying origami, maybe something like that. But yes, it will take quite a while to do that. And the James Webb Space Telescope is going to a Lagrangian point with the Earth and the Sun. So just like Lucy, we mentioned earlier, with those Trojan asteroids and those gravitational balance points with Jupiter and the Sun, the Earth has those too. And it's going out to one called L2, which is directly behind the Earth relative to the Sun. And that's going to be about 1 million miles away from us. So 4 times the distance on average from the Earth to the Moon. We do not have a spacecraft that crew can go in to get out there. So if something goes wrong on the James Webb Space Telescope, something's gone wrong. It's not Hubble. It's not in orbit around the Earth. We can't go up and we can't fix it. So it has to work right out of the gate. Sure hope it works, because, you know, it's very far behind in its schedule and it's very over budget by about $9.5 billion. But, you know, hey, it is an incredible system that nobody's ever done before. It was not just bleeding edge technology. It was literal new technology in order to make sure this mission would work. And as you can imagine, that doesn't come cheap, nor is it fast in order to do it right. Cheap, fast, on time, and, pick two. So that's the way it worked. Now, kind of going back here to Earth, we're going to have a flurry of new launch vehicles coming up. So if you're like me, you love some rockets. So this is like my wheelhouse. This is what I'm very interested in. But Blue Origin is working on their BE4 engine. This engine uses liquid oxygen as its oxidizer and methane as its propellant. It's fuel that burns. And that's pretty interesting. They've been having some issues with it. But if everything goes right, with the BE4 engine, the United Launch Alliance, which is one of the big launch companies here in the United States, is going to debut their Vulcan Centaur rocket in the fourth quarter of 2021. It's replacing the Delta IV and the Atlas V rockets, because ULA is kind of feeling the competition pressure to be cheaper and other things. And this is a video that their CEO Tori Bruno took and posted to Twitter, which that is the first stage. That is the first stage of a Vulcan rocket being rolled out, and it's going to the Cape, and it should be there pretty soon. And they're going to start processing it and seeing what they need to do in order to learn how to fly this brand new rocket for them there. So again, going to replace the 2 rockets that ULA currently uses, the Delta IV and the Atlas V. And yeah, this is very exciting. More rockets is better, if you ask me, because you got more providers, and each provider brings something unique to the table, and that's really important, making sure that we have access to space. You can't really just drop down to one, because if something goes wrong with one of them, then you got no ride to space. So it is actually really important to have multiple launch companies. And Inadvisable Science says, I love that name, Vulcan Centaur. I like it too. They actually had a competition back in 2014, I believe it was, to name it, and the names were like not very appetizing in terms of like what you would call a rocket. It was things like freedom or stuff, and like the last thing you want to say is free. We've had an anomaly with freedom. That's not exactly the best verbiage that I could ever think of. with that. So they sort of had like a other option that they took. And because it was around the time in 2015 when Leonard Nimoy passed away, somebody suggested Vulcan. So they threw that on, and that basically just destroyed everything else in the naming contest. And they all, and in fact, everybody at ULA ended up saying that's a much better name. So why didn't we do it right out from the beginning? It's called Vulcan because that's what people selected, and a little bit of Leonard Nimoy in it there in 2015 as well. The Centaur on there, actually the upper stage. Centaur upper stages are currently used on the Atlas V rocket, but this one on the Vulcan Centaur is a evolution of it. And in fact, the Centaur upper stage, you can literally trace its roots all the way back to the first Atlas missiles that were flying back in the 50s. Like it's not the same technology, but it has heritage hardware from that. It's just amazing that the system is still being used today because it's just that good. And the Centaur is the Centaur on this one, which they call Centaur 5, is an update of that. And it's gonna be very exciting to see this rocket in flight. And I can't wait. I can't wait to have more rockets. I mean, hopefully gets more payloads, which means more people get into space. And that's good for everybody. Japan has also got their own rocket as well that they're currently working on called the H3. This will be a updated rocket, cheaper and able to lift more than their current H2 rocket. And they are shipping it, or they were in the process of shipping that first stage to the launch site. But as you can see here, the first stage kind of slipped off of the tractor trailer that they were hauling it on. So I haven't seen anything yet as to whether they've noted any damage on it or not. If anybody who's in the chat knows, you're definitely welcome to throw that out at us and let us know, and we'll communicate that. But you know, that's a bit of a whoops, and we'll see if that ends up delaying it. It was supposed to be later this year anyhow, so it might be kind of a thing that ends up, you know, slipping to 2022. But also that's aerospace, things just get delayed. That's the way it works. If you want to work in aerospace, you better be very patient with things. So good luck, Japan. Hoping for the best, hoping that stage wasn't damaged, and hope to see that rocket flying pretty soon. And we've also got a lot of small sat launchers as well. Firefly Aerospace is going to be debuting the first flight of their first rocket, the Firefly Alpha, out of Vandenberg Air Force Base here in California pretty soon. They've already got the first stage there, and they're getting the second stage and the payload fairing and the payload that they're going to be lofting. They're actually taking student payloads for their first one, for their first flight, and not charging them at all. It's an educational initiative, and it's pretty cool that they're doing that. They just went to a bunch of universities and high schools and even middle schools and basically said, who wants a ride? And everybody jumped on it, and they're trying to lift as many people as they can during that flight. So it's pretty cool with that. So we got Firefly Aerospace working on it. No, I haven't got any word if the browncoats have approved that yet or not, but we'll have to see at some point. Then Relativity Space, who is local here in the Los Angeles area down in Long Beach, they are developing a rocket that is 3D printed. So you can imagine that's an actual test that they did of 3D printing a propellant tank. That's amazing, if you ask me. Their rocket called the Terran 1 is sort of in the mix right now, hopefully at a flight also from Vandenberg a little bit later this year, towards the end of 2021. Most rockets have tens of thousands of parts that make them up. The Terran 1 only has 760 parts, and they 3D print the vast majority of it, if not the entire majority of it. And that's just absolutely amazing with that there. Now, just to give a little shout out, Relativity Space did take part in a Rocket Fever event. So if you guys would like to know a little more about them, find a Rocket Fever event in our video section. And there are some segments with them. And they are 3D printing a rocket. They want to 3D print a rocket. I believe it's once every 60 days. That's wild. that's pretty that's something else, I gotta say. I never thought I would ever think about printing one rocket per 2 months, but there you go. They're on it and they're working it. Now it's not just private companies that are also getting into the mix for smaller launchers. This is the small satellite launch vehicle that's being developed by the India Space Research Organization. So NASA in India, ISRO, they are doing an excellent job in getting this ready to go. This should be launching sometime in the next month or two. So best of luck to them on the first test flight with that. And then Europe is getting their Vega launcher ready to upgrade itself. They've had some recent problems with their Vega smaller rocket, but they're going to go ahead and go to the upgrade, which is called Vega C. It's got a more powerful first stage that is also used on an upcoming rocket that the Arianespace is developing. And as you can see, it's bigger and it's got a wider diameter in some areas, so it's got more oomph, so it can lift more into orbit. So Vega C, basically like an upgrade, like dropping a supercharger on your car's engine. You get a little bit more oomph out of it there. So in Advisable Sciences, rocket tech has come a long way. Oh yes, it sure has. Gone are the days of creased slacks and slide rules. We're now doing things like rapid prototyping, where like, hey, I think this part, let's go 3D print this part in plastic real quick and see if it looks like what we want it to. And just a couple couple hours later, you got it right in front of you. It's pretty amazing. What a time to be alive, right? So pretty cool with that. And of course, one thing that may happen this year is the beginning of the competition for sending more and more humans on space flights. And specifically, this has been a long time coming from the two participants that are aiming to start taking people on suborbital flights. Virgin Galactic, which is here with their Spaceship 2, they've been working on it since the mid-aughts. So this has been over a decade of work to reach this point with them there. And they have done test flights where they have flown over the line that we designate as space. So they did one flight back in 2018 and another in 2019. Inadvisable Science says slide rules are still cool, though. I have to agree. I have my grandfather's slide rule that he used when he was an engineer on Apollo at home, and I love looking at it. And one day I'm going to figure out how to use it and show up in a calculus class with it and scare my professor or something. But Virgin Galactic here has done some test flights that have gotten to the altitude where Spaceship 2 has technically gone into space. And it's a suborbital flight. It goes up and then it comes back down. You go to space for a couple minutes. And there it is, lighting its engine as it goes. And then it's going to pull up and start going vertical. And that's White Knight 2, which is the airplane that carries Spaceship 2 up to 50,000 feet. And then eventually your engine runs out of fuel, so it turns off. And you just coast upwards until you reach the altitude that's space. The system it uses to come back, it swings its wings and kind of falls like a leaf, which is pretty cool. There's the pilots, as there are two pilots on this flight. They actually had the head of their astronaut operations come along on the flight. How nice is that? Like she works at Virgin Galactic and she got to take a ride. Like, that's great. Hey, Virgin Galactic, do you need anybody? I'm available. So that was very exciting to see that. And one of the pilots is Scottish, and once you have flown above that line, you are technically an astronaut. Once you break that altitude. So hey, I guess you got to have some bagpipes out there to celebrate that with it there. So that's pretty cool. Now, there's also Blue Origin. So Virgin Galactic, a lot of people know it because that's Richard Branson's company. A lot of people know Blue Origin because this is Jeff Bezos's company. And actually, with Jeff Bezos kind of stepping away from Amazon, a lot of people are thinking that he's actually going all in on Blue Origin because he literally, from what I understand, he single-handedly funds Blue Origin to the tune of nearly $1 billion a year. So, which is okay, so do what you want. But this is their New Shepard rocket, which has a capsule on top. So Spaceship Two is much more like a winged vehicle, and Blue Origin's opted for the capsule approach. With that there. But at some point this year, they should start flying people. Obviously, Virgin is flying crew on test flights. Blue Origin is close to flying crew on test flights. This is just a little sort of practice run that they're doing. These people did not actually fly on this, and Blue Origin has not flown anybody yet. But they have flown a ton of NASA experiments and college and other experiments, and that's really cool because it usually costs a lot of money in order to fly your experiment into space. But most of those experiments can be done in a matter of minutes. So just stick them on a suborbital rocket and you get the experiment back with it. So obviously it's very nice inside there. I sure wish I wish the inside of my house looked like this. That's pretty cool. Maybe not that chair. That doesn't look like I would be comfortable in it for any longer than 15 minutes. But hey, you get in you get in the New Shepard capsule. They light the engine. You fly up and up and up and up and up, and then eventually you cross the altitude that designates you in space, and you separate from the booster. So you kind of get to go on your own ride there. The booster does come back and land, and they do reuse the booster and the capsule. There's their test dummy, which they call it Mannequin Skywalker. I quite like that. And then there's the New Shepard booster coming in hot and landing. And I always like it because it comes down very gently. It's not like the Falcon 9 from SpaceX, which does I don't know if I would call it a hover slam, but it's definitely a bit different. And then that New Shepard capsule has a little sort of a system that puffs out at the landing to make it a little bit more gentle. And there you go, you've done your flight. Right now, if you want to buy a ticket, they're about $250,000 per flight. So unfortunately, I don't think many of us are going to be doing it for probably the next decade. But I bet within a decade, you and I will be able to do the equivalent of a 7 to 8 day vacation in cost to maybe go on a suborbital flight. And I will be first in line once it gets to that point, let me tell you. And of course, the thing that most people are exceptionally excited about this year, and I don't blame them at all, is the continued flights of this. It's very, very hard to not be excited by SpaceX's Starship test flights. That was SN8, the first one that they did back in December. They've flown SN9 just a couple of weeks ago, and that also resulted in a kaboom on landing, rapid unscheduled disassembly. Use my proper terminology there for it. And they currently have SN10, the next one, out on the pad, and they're doing tests on it to get it ready to fly. And probably in the next couple of weeks, it'll fly again. But it is a big beast. A lot of people don't realize just how big it is. This is how big those Starship prototypes are to scale with the space shuttle. And the space shuttle is about the size of a 737. So this is a big vehicle that's coming in, and it's pretty amazing watching all of these systems and techniques that SpaceX is developing that nobody's ever done before actually happen and then work. And I know they land with a big fireball and a big explosion, but they are test flights. And the purpose of a test flight is to gather as much data as possible, especially when you're flying things that there's no people or cargo or other things that are in. So these are sort of like pathfinders. You can imagine the Wright brothers, before they flew their Wright Flyer, they flew gliders in order to kind of see how things were going to work with their designs. And this is sort of like those gliders. We're sort of figuring out, well, what needs to be done in order to make this system work correctly. And that's pretty good. That's a right way to test it. And SpaceX has that attitude of move fast and break stuff. And that's an interesting attitude to have, not something you often see in aerospace. And then also the transparency as well, literally having live webcasts like we're doing, except to watch the Starship prototype flights. And when they explode, and they just go, oh, well, as you can see, it didn't land. It's like, well, I don't think you needed to tell us that. I think we saw it. But I have a feeling that their next one isn't going to quite nail the landing, because SN8 there was a pretty nice, that was nice and stable on its way. SN9 was way off of the mark. It was leaning almost 45 degrees coming down. So we'll see if they can do it with SN10. I don't think they are, but these are things that I always love being entirely wrong about. So I have zero problems with being wrong about that. So that is our little presentation that we had for everything that's coming up that's exciting in 2021. There are other things as well, but we got to kind of keep it a little bit with it. And we do have some time for questions. So if there are any questions, you can go ahead and throw them in the chat room, and we'll kind of hang around for, I guess, what do you think, Rick? About 10, 15, okay, yeah, we can do that with that there. So we'll just hang around for some minutes here, and we'll just go until Rick tells me to stop and make that happen. So, but if you have any questions, feel free to ask. If not, thank you guys so much for watching us here today. I'm really excited. In March, we're going to be talking about Perseverance and its mission in great detail, and ingenuity as well. We're also going to give you a little bit of an understanding of exploring Mars and in our history of exploring it, and the work that's gone into it, the engineering and the science and other things like that. So SO wants to know more about that asteroid we're looking at around Jupiter. What science is happening? So I think you're talking about Lucy, which is the mission to the Trojan asteroids around Jupiter. So as we mentioned before, actually, I'm going to jump back in the presentation here and pull that up so we can actually take a look at Lucy, where it's at. In here. So just give me a moment. Sorry about that. I'm gonna pull this up just to make sure I could give you a nice sort of cohesive idea as to what we're looking at here. So we're looking at the Lucy mission to those Trojan asteroids around Jupiter. And as you can see at the bottom of the screen here, at the bottom of that circle in the screen, the orange one, you can see a little dot there, and that's Jupiter. On either side of Jupiter are those white dots, and those white dots are Trojan asteroids. Now, there are a lot more than that right there, but obviously we're not going to show all of them. The white dots that are bright are bigger than the rest of them. Those are Trojan asteroids that Lucy is going to do flybys of, and Lucy will be looking at these because we think these Trojan asteroids are sort of the leftovers of our formation of our solar system. These are objects that are under the influence of the sun and Jupiter's gravity. So the sun and Jupiter, they gravitationally interact with each other. Obviously, the sun wins because Jupiter's in orbit around the sun. But there are these interesting areas called Lagrangian points where you can actually put an object there, like a spacecraft or something, or in this case, asteroids, and they will stay in that same relative area because the gravitational pull of the sun, and in this case, Jupiter, balance it out very nicely. So they tend to stay in the same area. So there's one group of Trojan asteroids that's in front of Jupiter in its orbit. There's another group that is behind Jupiter in its orbit, and they just call them the Trojans. I believe there is a designation. One's called the Greeks, the other's like the Romans or something like that. But Lucy will be going first to the Trojans that are in front of Jupiter in its orbit. And as you see here, as Lucy's actually going out, it's going to rendezvous with an asteroid on its way out. So they're going to fly by an asteroid within a couple of years, and they're going to fly by it and sort of do tests and everything with it. And then Lucy's going to go into that front area, and it's going to do some very fast flybys. All those flybys happen within 13 months of each other. 4 flybys in 13 months. That is rapid. And then Lucy's going to spend 6 years diving through the inner solar system and going to the other side of Jupiter's orbit. That is impressive to be able to pull off that kind of orbital mechanics with a spacecraft. And once it gets over there, it will go by a binary asteroid that's actually very, very large. One of the biggest asteroids that are binaries, like 80 miles in size, and they both orbit a point around in the middle. So Lucy's pretty exciting because of that. So sure are hoping that we get a very cool view of it there. So yeah, that's Lucy with you there. So, and we're studying those because we think they're the leftovers, and they can tell us what the early solar system was like, and that tells us a lot about how planets form and other things. And then we can apply that when we do astronomy, looking at exoplanets and nebulae and other things, and it kind of all intermeshes together, which is pretty cool. Inadvisable Science is asking, do you think there will ever be a crewed mission to an asteroid or a moon on one of the other planets in our solar system? Absolutely. I think we're definitely going to do it. I don't know when it's going to happen because, NASA is looking at Artemis, which is return people to the moon by 2024. We'll see if 2024 holds simply because schedule, it is what it is in aerospace. So that's just the way it goes. Safety is the first priority. So we can't, you can't fool nature on that front with it. So we want to make sure it's as safe as possible. And then also Mars is the target as well. I know Elon Musk at SpaceX says that they're going to launch a crew to Mars in 2024. That's not going to happen. I'll just say it outright. That ain't happening simply because there are so many things that they have to get together at SpaceX. Things like life support. How do you get life support to last for years at a time? We can barely be able to get it to work on the International Space Station for months at a time. Yeah, and then also radiation protection for Mars, because you even have to do a little bit of radiation protection at the moon as well. So because that's just kind of it's just kind of how it goes. So those are a lot of questions that have not been answered really by anybody, honestly. So it'll be really tough for them to do it. I think more like 2028. If SpaceX is the one leading the charge, I think it'll be 2028, that window when they do it. And they kind of have to test things first. They're gonna have to send cargo starships first to see if they can actually land them on Mars. But I would imagine it seems like they're cranking a starship out every other week at this point. So I'd imagine they'll probably send a large flotilla of starships during the first window that they can, and then see how they land and look at the data from landing. And if one doesn't land successfully, they'll apply those lessons learned to the next one's coming in hot, a day later, something like that. So we'll have to see what happens there. But yeah, I think I would be very surprised if we don't end up exploring astronauts and other moons around the solar system. I think the first moon that will actually be at the solar system besides our own will be Phobos, the moon of Mars. I think that's a really good spot for a human outpost there. And then near Earth asteroids, we might send humans there. Robots are a lot easier easier just to work with, and make a little bit more sense with that. But also asteroid mining is a thing. So we'll see if humans end up being in the loop of that. Probably not, but we'll have to see. We'll see how it goes. And that is our nice conclusion, a nice optimistic look at things with humans going out into space to wrap up our first Space Center Live of 2021. Thank you all so much for coming. Just a reminder, we're going to be back in March. We'll be talking about Perseverance and its landing, regardless of whether it works or not. Have to see. Nothing is ever guaranteed. That's for sure. So remember, landing is happening on February 18th, this Thursday. Broadcast will start at about 12 p.m. Pacific Standard Time, 8 p.m. Coordinated Universal Time. Figure out with your own time zone there. NASA's YouTube channel, youtube.com/NASA. Also mentioned JPL, youtube.com/NASA-JPL will be broadcasting. Maybe someone, wherever you're living, like a major news organization, maybe broadcasting that as well. Take a look at that. Hopefully in the United States, we'll have a couple. And then wherever you live at, just check in and see if that may be happening as well. And then, like I said, in March, we'll be talking about it in great detail. The exploration of Mars, what Perseverance is doing, what Ingenuity is doing, and why you should even care about exploring about Mars. So thank you all so much for coming to this Space Center Live. This has been so much fun talking with you all, and hopefully you guys enjoyed today, and I'll be seeing you next time. And until the next one, remember, keep exploring.